Hi, welcome back to our channel. Today we are going to discuss about, in the first session we have been discussed about what is meant by the basics of electrical circuit, what is meant by a network, what is meant by a network analysis, and we discussed what are active elements, what are passive elements, and the second session is continued with linear elements. So what elements are called linear elements and what elements are called non-linear elements, and we are going to discuss about what are unilateral elements and what are bilateral elements, what are lumped elements, what are distributed elements. With this session, you will be getting a clarity on these 6 types of elements. First one, already I told, this is called as an resistor, this is called as an inductor. So the units of this resistor is ohms, the units of this inductor is Henry, the units of this capacitor is farads. If you express in ohms, you can write down this as a directly ohms. So these are the units in the case of an DC. The units in terms of AC is, this is directly written as ohms. Here you are going to write down it as plus j x l ohms. Here minus j x c ohms if you express in terms of AC. Already I discussed in the previous. So now let's try to discuss what are linear elements and non-linear elements. So already I told, so when you plot a graph, let's try to understand what is meant by linear elements. So linear elements means, actually these are the elements for the variation of input voltage, the current developed is also proportional. For example, you applied a voltage of 1 volt, the current developed is 1 ampere. You applied a voltage of 2 volts, the current developed is 2 amperes. You applied a voltage of 3 volts, the current developed is 3 amperes. You applied a voltage of 4 volts, the current developed is 4 amperes. So here the relationship what I have is current I is equal to V by R. So what is the voltage we applied? 1 volt by, I am taking this R as 1 ohms, so it develops a current of 1 ampere. So current I is equal to voltage of 2 volts by R. R is 1, automatically it develops a current of 2 ampere. Current I is equal to 3 volts divided by 1 ohm, it develops a current of 3 amperes. Current I is equal to 4 volts by 1 ohm develops a current of 4 amperes. Here you can see here the relation between the variation of voltage and current is an linear, or this is relation we call as directly proportional relation. Okay, so the relation between the voltage and current across the elements like R, L, C, the relation is linear or directly proportional, then these kind of elements are called linear elements. Sir, how to draw this? You can see with a graph. So in order to understand better, I am taking the current in the x-axis. Here the current is minus I ampere. Here the voltage is positive voltage. Here the voltage is minus negative voltage. So how much voltage I applied? So here I am applying 1 volt. Okay, 1 volt I applied, and what is the developer current? 1 ampere. So I am drawing an vertical lamp which is nothing but 1 ampere. This is one intercepting point. So how much voltage you are applying in the second step? 2 volts you applied. So automatically 2 volts I applied, it develops a current of 2 amperes. So this is the next intercepting points. Next you are applying a voltage of 3 volts across the element. It is developing a current of 3 amperes. Here you are going to get 3 intercepting point. This is intercepting point 1, this is another intercepting point. So from the origin, if you join all these lines, then you are going to get a straight line. So similarly, here I am going to apply current of minus 1 ampere. The current developed voltage is minus 2 volts. I mean minus 2 volts I applied, current developed is minus 1. Okay. Here I am applied a voltage of minus 3 volts. Therefore the developed, sorry, here I applied 2 volts, the developed current is 2 amperes. Here I applied minus 3 volts, the developed current is minus 3 ampere. I'm going to get one more intercepting point. If you take it 1 also, you get one more intercepting point. This is intercepting point 1, at minus 1 volt and minus 1 ampere, at minus 2 volt minus 2 ampere, minus 3 volt minus 3 ampere. So when you join all these points, then you can see here this is having a slope y is equal to mx, m is equal to y by x. Y is how much? 1 volt. Current is how much? 1 ampere. Slope is how much? So what is the slope? We are going to get v by I is nothing but 1 ohm. So here the slope is positive. If the slope is positive, I can say these are linear element. This is a linear element. Here the slope, if you find out y is equal to mx, m is equal to y by x. What is the y axis? Let's take minus 2. So here what is the y axis? Minus 2 volts divided by what is the current? Minus 2 ampere. Minus minus will get cancelled and you are going to get 1 ohm. Why? Because the formula for current I is equal to V by R. But I require V by I. Therefore, R is equal to V by I. If you compare with this, what are the units you are going to get? 1 ohm. Therefore, you are going to get 3 points. Here the slope is also, what is the kind of slope? Here the slope is positive, and if the slope is positive, I can conclude indirectly the relation what they are going to exhibit is a linear relation between applied voltage and the generated current. What we generally apply is voltage. We apply voltage. What is developed? Current is developed through resistor. So what I want to say is current is developed. What we are going to apply? Voltage is applied by the resistance offered by the network in terms of ohms. So here when you compare voltage, we are applying through a voltage source. For example, 10 volts you applied. And what is the resistance of the network? 1 ohm. So 10 by 1, what is the current developed is 10 amperes. That is absorbed through an ammeter. So these kind of elements are called, so these properties are exhibited by the elements resistor, inductor, capacitor. So the linear elements are resistor, inductor and capacitor, which exhibit this, the graph of IV curves. So this characteristic curve is called IV characteristics of an linear element. Is like an straight line. And here if you draw also, you will get also an straight line. These characteristics in second quadrant as well as fourth quadrant, you can, if the line is straight line, you can call these elements as which type of elements? Linear elements. So whatever the relation between the voltage and current, voltage applied to the current developed is a linear relation, then we can call these elements as. So what is the circuit for this is, you have an voltage, you applied, this is an resistor. Okay, you take, if it's like an AC supply, it's very simple to understand. Okay, so this is an R. What you applied? Voltage you applied. What is the developed component? Current is developed, and the relationship between this applied voltage and current developed is V by R. Current I is equal to V by R. Here I am taking it as a 1 ohm. I can say here applied voltage and current has an linear relationship. That's how it is there. And similarly, you are having an AC supply and you are applying to an inductor, and this can be written as minus JXL ohms. What you applied? AC supply you applied. So what is developed? Current is developed. So you applied AC supply. What is developed? Current is developed. How current is developed? Current developed is equal to voltage applied divided by ohms. This can be written as plus JXL ohms. This is ohms, this is voltage. Then what is developed? Current. I can say the relationship between applied voltage and developed current is proportional. That's what already explained. This is what the relation exhibited between the voltage and current for the resistive element, inductive element as well as for the capacitive element. So similar, we are going to have the property for an capacitor also. This is an AC supply and we are going to have a capacitor. So voltage AC is applied and this is capacitor. If when expressed in AC form, this is minus JXC form. So voltage we are applying, what is developed? Current is developed. How the current is developed? Applied voltage to the resistance. Here there is no resistance. This resistor we are writing it as minus J XC ohms. Therefore, V by R, this is nothing but current is developed. Therefore, the relationship between already I discussed, 1 volt you apply, current developed is 1 ampere. 2 volts you apply, current developed is 2 ampere. 3 volts you apply, the developed current is 3 ampere. The relationship between these components, applied voltage and developed current, are an linear relation. They exhibit a linear relationship between applied voltage and developed current. Therefore, these elements are linear elements. Therefore, the example of linear elements are resistor. You see here, this resistor is a linear element, this inductor is a linear element, this capacitor is a linear element. The relationship between the applied voltage and current is linear or directly proportional relation. That's why these elements are called linear elements. Sir, how you define a non-linear element? Very simple. Okay, so non-linear elements. Sir, what are those non-linear element? Means the relationship between applied voltage and developed current is not directly proportional. For example, the developed current may be I square. So how much you applied here? So you apply 1 volt. The developed current is 1 square. You apply 2 volts here, the developed current is 2 square. So 2 square means how much? 4 amperes. Here current is 1 ampere. So applied voltage is 3 volts, the developed current is 3 square. So 3 square means 9. You can see the relation: 1 volt 1 ampere, 2 volt 4 amperes, 3 volt 9 ampere. So this kind of relation is called hyperbolic relation. Okay, so this relation is like, if you try to draw the graph of current on the x-axis, this is minus current, this is positive voltage, this is negative voltage. This graph will be like this. It comes here and suddenly cut off point, suddenly it rises like this, suddenly it goes like this. So this is called active region, this is called amplifier region, this is called saturation region. So multiple regions are exhibited. So you see the curve, the applied voltage and current are non-linear. So voltage what we are applying to the developed current is not an direct relation. It may be 1 by current, or it may be current square, or it may be current cube. There is no direct relation. Automatically the curve exhibited by this. Sir, why this kind of non-linear is? This is due to the properties of those elements. Sir, what are those elements? All electronic devices exhibit. So what are those electronic devices? You have bipolar junction transistor, metal oxide semiconductor field effect transistor. So this is nothing but junction field effect transistor. This is integrated bipolar transistor. You can see here all are transistor. Transistor means transfer of resistance from input to output. That's why they are called transistor. So these elements behavior is linear, but these elements behavior is non-linear. The applied voltage and current are non-linear. Sir, why non-linear? Means these are designed like this. They want non-linear characteristics. So suddenly it will be, so as soon as you apply the voltage also, it will not turn on. So current is here. For example, if you take dead zone, so if you apply the voltage also, current is 0 here. So when it comes to the cut in region, once again the current will drastically increase. Why? Because it has came out of cut in voltage. So now current rises. So as soon as you keep on applying the voltage, the current gradually increases. This is called active region. So if you apply the voltage also, the current will not further increase. The current maintains a constant magnitude, where this is called saturation. So multiple regions are exhibited by these elements. Therefore, I can claim these kind of elements, especially this transistor family of elements, as non-linear. You can see this here. So this is the symbolic representation. This is the physical power electronic devices where they exhibit non-linear characteristics. Therefore, I can say here very simple means a non-linear element can be defined as for the applied voltage current is non-linearly related, or it may be 1 by current developed, or it may be developed current square, or it may be cube, or it may be root of. So the relation is not linear. That's why these are called non-linear elements. The examples are all the electronic devices including diode is called as an non-linear elements. So how to understand this is called non-linear elements, or you can say this non-linearity like this. Okay, so this is how to understand linear elements and non-linear elements. Let's try to have an overall lookup. So linear elements means for the applied voltage current developed is linear. So the relationship between voltage applied current is linear, and it is like a straight line which travels in the first quadrant as well as in the third quadrant, as well as it travels in second quadrant as well as in the fourth quadrant. These elements are called linear elements, but there are some elements, the relation, for example, this is like this, and here this directly it comes to saturation region. So this is called negative cutoff. The element behavior is not clear. It changes as per the region of operation. I can say here this is not same in the first quadrant as well as in the third quadrant. Then these kind of elements can be claimed as nonlinear elements. The applied voltage and developed current has a nonlinear relation. The examples are these transistor family of elements, diode also. This is very clear about a linear element as well as a non-linear elements. Now let's try to go into in clear what are unilateral as well as bilateral elements. So this is also very important. Unilateral. Let's try to discuss first bilateral, then you can understand better. Okay, unilateral elements and bilateral elements. So what are bilateral? You can see here bi means two, lateral means they allow. So these elements allow the current in two directions. For example, I am taking an active element is some voltage, some 10 volts. I am connecting an resistor. So therefore the current flows from top to bottom with the polarities of positive, negative, and this is the developer current. So therefore I am labeling this R is equal to 1. Okay, let's try to understand this current as some 10 amperes. Okay, so therefore current I is equal to 10 volts divided by V by R. So R I want to find out, but current is also known as 10. Therefore R is equal to 10 volts by 10 amperes. Therefore what is the resistance offered? 1 ohm. But for the same resistor, what I am going to do here is I am going to change the polarities. So like this I am applying the voltage. So voltage is reversed here. Okay, therefore current is, so the current will flow in this direction. Therefore the direction of current is how much? Minus 10 amperes. Therefore the relation we are going to have R is equal to V. What is the voltage? 10 volts by a current of 10 amperes. Okay. So therefore how much resistance you are going to get? Minus 1 ohm, which says that the resistance offered, so if you take the magnitude of this, the resistance offered under forward bias direction or in reverse bias direction, the resistance offered is same, or impedance offered is same, whatever may be the flow of current. So these elements are called bilateral elements. So this bilateral property is generally exhibited by our resistor, this is generally exhibited by our inductor, this is generally exhibited by our capacitor. So this resistor, inductor, capacitor allow the current in by times. By means two directions. So it can, current can flow from top to bottom, or current can flow from bottom to top. It allows. Therefore those kind of elements which allow the current in both directions, it may be in forward direction or in backward direction, current may flow from top to bottom or bottom to flow, but whatever the resistance it is supposed to offer, it is offering same. So this I am going to write down it as plus j xl ohms. What is this ohms? I mean resistance offered is 1 ohm, but in form of plus jxl if you take in the case of an inductor. Okay, so let's try to see the same behavior how we written for resistor. Inductor also will be there. but inductor we can get minus jxl is equal to 1 ohm minus jxc is equal to 1 ohm when you replace the voltage source. This is a voltage source, and here we are going to get an inductor. Here we are going to have an voltage source and we are going to have an inductor. So but here the current flow is like this. This is the developed current. The current flows from top to bottom. This is nothing but plus jxl. I am assuming a current of 10 ampere, applied a voltage of 10 volts. Reverse, the voltage is reversed now. Like for current will flow in this direction, and the current is now minus 10 amperes. The inductance is plus jxl. Now I want to calculate the amount of inductance. This is like take it like um, AC supply, then you can understand very clear rather than DC supply. So here in this concept, what it happens here is, so current I is equal to V by R, but what we require is R. R is equal to V by I. So what is the V? 10 volts by 10 amperes. So this nothing but, this R is nothing but plus J XL ohms. How much you are going to get? 1 ohm. So this is from flowing from top to bottom with the polarities of positive and negative. So this is also going from bottom to top. So therefore R is nothing but plus jxl ohms, here minus jxl ohms. Here also you are going to get 10 volts by minus 10 amperes. If you take the magnitude of this, then plus jxl is also 1 ohm. So what you understand? It may be an resistor, or it may be an inductor, or it may be an capacitor. The resistance offered by those elements is same. It may be in DC type or it may be in AC type. So therefore these kind of elements are called bilateral elements. You can see these elements in this diagram. So this RLC allows the current in forward direction as well as backward direction. Allow the current in forward direction as well as backward direction. So current can flow like this, or current can flow in this direction. It can flow in this direction, or it can flow in this direction. It can flow from this point or this point. Both the direction it allows. Therefore RLC are bilateral elements. So this is how to understand the bilateral elements. These elements are generally called as electrical elements. These electrical elements as bilateral in nature. Okay, so the beauty of this, why I written converted this DC to AC is, so DC we cannot directly write down it as inductance. We need to transform it. But when you change the type of source as AC source, the analysis become easier. The inductor can be represented in ohms, which is nothing but plus jxl. The capacitor can be represented in ohms as minus jxc. So easily you can transform and easily you can express in ohms. This plays a major role. Now let's try to understand the next one is unilateral elements. Unilateral elements. The name itself, uni means they allow the current only in one direction. So what are those elements? All electronic devices. Okay, so this transistor family, diode, GNR diode, Shockley diode, and all these electronic devices, complete electronic devices like diode, BJT, bipolar junction transistor, UJT, all this transistor family components, Shockley diode and GNR diode, all this are unidirectional. Sir, what is uni means? So they allow the current only in one direction. Already you studied in intermediate level. So if you apply DC voltage, and this is the diode, okay, so you can see here voltage we applied and the diode is in forward bias, then what is developed? Current is developed, then only this diode will conduct. But the same diode I reversed the terminals as like this. Now this doesn't allow the current in this reverse bias. I am assuming the current is 0. It is acting like a open circuit. Now let's try to calculate the impedance here, or you are going to calculate the resistance. We have the formula current I is equal to V by R. What we require is resistance. Resistance is equal to V by I. So we applied a voltage of some 1 volt and current developed is 1 ampere. So therefore what is the resistance of this diode is 1 ohm. And here you can see here the resistance is only 1 ohm. But in this case what happens here is R is equal to V by I. So you applied a voltage of 1 volt, but current is 0. Whenever the current is 0, anything by 0, resistance is infinity. So here the resistance offered, I mean this network, when you draw with infinity resistance means, so resistance is infinity. If resistance is infinity, current is 0. You can see here, in forward bias the resistance offered is 1 ohm. In the reverse bias the resistance offered is infinity. So there is an change of resistance. Therefore the resistance changes in unilateral elements. These elements are designed to allow the current only in one direction. They doesn't allow the current in reverse bias. So, and I can say here, the resistance offered in forward bias is different, the resistance offered in reverse bias is different. So when you come here in detail, if you understand, in forward bias what happens is, current is maximum current can flow in forward bias, therefore resistance offered is minimum, the resistance is minimum here. But in the case of a reverse bias, so the resistance, the current offered is I mean here the current is maximum here, so current is minimum here. Whenever the current is minimum, the resistance offered is maximum, therefore resistance is infinity. I can say in forward bias resistance is too low, in reverse bias resistance offered is high. We have different variations of resistance, therefore these kind of elements which have this behavior are called unilateral elements. The examples are all electronic devices, diode, BJT, MOSFET, triac, diac, and all the transistor family exhibit this unilateral behavior. Hope you got a clarity what is meant by an linear elements. I mean resistor, inductor, capacitor are linear elements. Transistor, diode, triode, Shockley diode, all these are non-linear elements. The voltage and current relations are non-linear. So resistor, inductor, capacitor are bilateral elements, but these electronic are unilateral elements. They allow the current, the name itself is very clear, they allow the current only in one direction. Okay, so that is all about unilateral elements, bilateral elements, active, I mean linear elements and non-linear elements. So we'll discuss about this lumped and distributed in the upcoming class. Okay, so this is all about, or let's try to conclude this lumped and distributed elements also. Okay, so one more kind of elements are lumped elements. Lumped elements, and next is distributed element. This is very important. This plays a major role for electrical students. Lumped elements and distributed elements. Sir, what is the major difference? So here lumped elements means the examples are RLC. Sir, how you are saying RLC are lumped elements? Lumped means these elements are physically separable. So these are physically separable. I mean we can separate them physically. For example, I can write down resistance is equal to 1 ohm, inductance in AC form plus JXL is equal to 1 ohm. So capacitance minus JXC is equal to 1 ohm. So I can separate them. I can separate, you can see here these elements RLC, what I am showing here, this resistor, inductor, capacitor, they are physically seen and these are physically separatable. So those elements are called lumped elements, and their value is also very clear, 1 ohm, like this 1 ohm in resistor, here in inductor plus JXL 1 ohm. But there are some elements in electrical engineering, those elements are called distributed elements. Here the examples of distributed elements is transmission, electrical transmission line parameters, and underground cable parameters. Here we can, how to describe this is, for example, we cannot physically non-separable, so we cannot separate them. So these distributed elements are physically not separable. Non-separable means we cannot separate them. So how they will be means, for example, resistance at 1 meter is equal to 1 ohm. Resistance at 2 meters is equal to 2 ohm. Resistance at 3 meters length of the wire is equal to 3 ohm. Resistance at 4 meter length is 4 ohm. You can see here, with the increase of length of the wire, what is increasing? Resistance is increasing. This is related by the formula R equal to rho L by A. With the increase of length of the wire in a transmission line or length of the wire in an underground cable, the resistance increases. Therefore, these elements are called as a distributed elements, and you cannot separate them. So physically they are not separatable, or physically they are not separable in form. With the variation of length, resistance is variable, but here you see, here the resistance is fixed but the resistance is variable. Okay, so you have an variable resistance. Therefore these kind of elements are called distributed elements. Sir, what are lumped elements means? So if you, the elements are lumped, then only you can apply your Kirchhoff's current law or Kirchhoff's voltage law. So you cannot apply the, so here KCL, KVL are only valid, but in the distributed elements you cannot apply Kirchhoff's current law, and you cannot apply Kirchhoff's voltage law also. You cannot apply in the case of an distributed elements. So these elements plays an major role. The analysis in distributed elements is very complicated, but the analysis in lumped elements is very simple. So it's very simple to understand. Lumped elements examples are R, L, C. These are physically we can represent their quantity as 1 ohm, 1 ohm in inductance form, in capacitance as 1 ohm. But in distributed elements, the value is physically not separable. In the case of a transmission line, in the case of a underground cable line, the length increases, resistance increases. With the variation of length, resistance also increases. Therefore, these kind of elements are called distributed elements. The examples of a transmission line parameter or underground cables, they have variation of length of the cable, variable resistance, and you cannot say that what is the uh, value. You cannot fix that value also. Depending on length, it is going to change. Those kind of parameters are called. That's why it is called distributed. With the variation of length, the resistance is distributed throughout the length. With the increase of length, resistance is distributed. So length of 1 ohm, 2 ohm, 3 ohm, 4 ohm, it is distributed throughout the line. Therefore these are called distributed elements. So now you got a clarity of the class. What are linear, non-linear elements, what are bilateral elements, what are unilateral elements, what are lumped and what are distributed elements. Very good, important to know about these elements and their behavior. So hope you understood the class, and if you have any doubts, let me know in the comment section. So if you feel the content is really useful for you, please give your valuable like, and please share with your friends. And if you're watching the channel for the first time, subscribe to the channel, and this is a free channel for the benefits of student and faculty. And thank you for watching. We'll meet in the next video. Yours obediently, Ram. Thank you for watching.